Our next presenter is going to be Dr. Feliu Sempere. He is a chemical engineer with very prestigious academic credentials and international experience, and also expertise in waste treatment and biogas purification. He has joined Global Omnium in 2019, and since then he has been engaged and involved in many interesting projects, which has led to this project today, the LIFE Waste2Coag. He's leading the technical coordination of the project at Global Omnium, and assists the project coordinator, Tatiana Montoya, in this project. So now Feliu is going to provide us an overview of the project and latest advances. Thank you, Feliu. The floor is yours.
Thank you, Blanca. Hello, everyone. Do you see my presentation? Okay.
Not yet. Not yet. Now we see it.
Yeah. Now? Okay, yeah. Perfect. Okay, this is the content. I will start with the context, the concept of the waste-to-coke solution, and overview of current status, and also the afterlife transferability. Okay, the context is the problem to solve. We have a high worldwide coagulant consumption, which is applied mostly in urban wastewater treatment plants, but also for industrial wastewater treatment. Okay, there is a continuous price increase, and normally we have to outsource this, which indeed, for example, in the UK, the coagulants have been defined as critical goods, right, for industry. And as said, if coagulants are expected, the consumption to keep increasing, also to more stringent regulation on final effluent values in wastewater treatment plants. Also, there are a huge brine disposal from desalination plants, from 142 million per cubic meters per day, also in desalination, but all other industries also produce brines. And these brines, 80% of their production is released below 10 kilometers from saline water bodies, but 50% of this production is also away from saline water bodies, which difficults its handling, mainly in China, USA, and Spain. And the release of these brines, regardless where they are released, pose an environmental impact in the receiving bodies. So our concept of the project is based on electrolysis with the valorization of brines, both wastes, brines and metal wastes, into coagulants. Okay, this was carried out by IDEME and Global Omnium since 2015. From laboratory reactors to pilot scale reactors of 100 liters, which was the previous project, using, as mentioned, an electrolytical technology to produce the iron and aluminum-based coagulants. Just to highlight what the electrolysis is about, is to apply a continuous electrical current to two metal electrodes to cause a non-spontaneous chemical change. If we use as an anode a sacrificial electrode, steel or aluminum, we are producing the substitute of iron-based coagulants or aluminum-based coagulants like PAC. Why we are using brines? We are using brines because the higher conductivity of these solutions allows to apply lower voltages. So that implies a lower electrical consumption in producing these coagulants. And then this led us to the current project with a total amount of 1.5 million euros co-financed by the European Commission under the LIFE program. The project finishes after an extended time requested and approved until September next year. And we have IDEME, Jovial as partner for industrial wastewater treatment plant, ILE, who is organizing this webinar, Aquafin, and a water utility in Belgium, and Global Omnium, also a water utility. Summarizing the project, the packages that we have in the project is the obtention of administrative permits, the design and construction of the prototype, which was led by IBIME, the optimization of the prototype operation to produce the coagulants, and their application in wastewater treatment, which is an action that just finished. And then their validation of these coagulants into urban wastewater treatment plants in Spain and Belgium, and also in an industrial wastewater treatment plant in Jovial, in Spain. ILE is leading the market access and exploitation of results, and also we have as an action the environmental and socioeconomical studies of the solution, the dissemination activities, and finally the monitoring the impact of the project, and of course the coordination of it. Today, nowadays, we are in action B5, the transferability of the industrial plant in Jovial. Here you can see a picture of the HMI of the plant, where it's schematics of the process, a receiving tank for the brines, the electrolytic reactors, which we see here in the picture on the right side, and then a receiving tank of the coagulants from where they are dosed to the wastewater, industrial or urban wastewater. We have 3 demo sites, 2 urban wastewater treatment plants with different brine characteristics and from different origins, and also an industrial wastewater treatment plant to transfer the results to a totally different type of wastewater, and also dealing with a different amount and conductivity of the brines produced, which are in the same factory. As a result, we checked the purity of the scrap metals used as electrodes, and they were compared to commercial electrodes. And what we saw is that the purity of these metals was very high, with, in case of aluminium, about 96% aluminium content, and in the case of iron, almost 100% content. And the production of the coagulants, what I would like to highlight is that on the left, we have the results of previous R&D projects. Based on the concentration of coagulants, we reached 200 milligrams of aluminum per liter, and now in this project, at different electrolysis time, we increase them to 1 gram per liter, which increases the valorization of brines. Let's say for the same amount of brine, we can produce more coagulant. And this is done using a lower energy consumption per kilogram of metal, compared also to previous projects where we have values as high as 60 kilowatt-hour per kilogram of aluminum. And this is a result of the high conductivity of brines that we are treating in this project. And then we also evaluated the toxicity of these coagulants, which we have in this slide with respirometry test, both on autotrophic bacteria responsible of nitrification, but also on heterotrophic bacteria. What we made trials with activated sludge of respirometry to evaluate the oxygen consumption, and also activated sludge with the alternative coagulants, which we are producing. And what we saw is that there is indeed a boosting of the respirometry in both type of bacteria. This is not the objective, to boost respirometry, but to check if there was any inhibition on the biological process, which clearly these results demonstrate that they are safe to be applied in biological reactors, as those that will be used in urban wastewater treatment plants. And then after this, looking forward towards after the end of the project, we are looking for transferability to test different type of brines, to be able to process them initially maybe at laboratory scale and afterwards in the demo plant. and also to apply our coagulants to other wastewater, different type of wastewater. So we are happy to assist you if you want to reach us. So for that, you can contact either ILE or ourselves as coordinators in this email or visiting the webpage. So just to finalize the conclusions, the brines and metal wastes are correctly valorized. The electrolysis concept has been correctly scaled up from previous projects. And these coagulants are safe to be applied on activated sludge reactors, and we look for networking with other stakeholders. So thank you for your attention, and if you have any questions, I'll be happy to answer them.